point C, we are asked for the strata stretch in the input pin at the top of the piston C if its diameter is 22 millimeters. To determine the stretch on the input pin at the top of piston C, we can use the stretch formula. If T equal E, where T is the stretch strip, F is the applied force, E is the cross-sectional area over which the force acts. In this case, since we have the diameter of the pin, we can calculate the cross-sectional area using the formula for the area of the cycle. Subject to Newton's value, we have D equal 22 millimeters, area equal P, diameter sobre 2 squared, area equal 379.94 millimeter squared. Using the applied force of the 17857.143 newtons and the calculated cross-sectional of approximately 379.94 millimeter squared, we can determine the stretch in the input pin. T equal 379.94 millimeters squared. We converted the area to the square meters. T equal 0.0003794 meters squared. Finally, T equal 7.005.102.99 pascals.
The point B asks for the normal stretch of the rod BC, which has the uniform cross-section area of 450 square millimeters. Since we already have the force acting on the rod and its cross-sectional area, we can use the equation for normal stress. Normal stress is force over area. Substituting the values, we get normal stress equal 1864.39 over 450 square millimeters. Simplifying the units and performing the calculation, we obtain 41.43 multiplied 10 raised to the 6 Newton to square meter. We know in the international system of units, 1 Pascal is equal to Newton to square meter. Therefore, we know that 10 raised to the 6 pascals is equal to 1 megapascal. Thus, the answer is less 41.43 megapascals. Negative because it is compression.
17.857.743 newtons. In this way, the diagram will remain with the forces active so far. Point B asks you for the normal stance of the connected rod BC, which has a uniform cross-section of 450 millimeters. Since we already have the force on the connected rod and its cross-sectional area, we use the normal stress equation. BC igual 18.643.393 newtons. With the data of PVC, we can find the force P summing on the J axis as follows. Subject PVC, we have P igual 18.643.393 newtons for 200. With this data, we can find the point A of the problem, which is the force P required to keep the engine system in equilibrium. We do it by summing the forces in both X and Y. For X, we have to calculate these forces. The angle must be calculated, for which it will be solved as follows. For the length of the connected route BC, we use the Proyecto theorem. Raíz cuadrada 22 plus 602. The result is 208 plus millimeters.
To start with the solution to this exercise, the free body diagram drawn and point A, which is as follows. Now with the free body diagram, we proceed to clear the unknowns shown. The first one we find is the normal force, making an A and sum of moments. Substituting, we get sum of moments in point A is equal 0, rest 1,500 meter, least normal strength by 280 millimeters. We pass the units from the millimeters to meters to operate equal units. Sum of moments in A is equal to 0, 1,500 Newton by meter less normal strength by 0.208 meters is equal to 0. Since we only have unknown in this equation, solve for A. 1,500 Newton by meter be 0.208 meters is equal to 0. Operating, we find the normal force N, 5,357.143 newtons. The normal force is negative since its direction is towards the other side. Therefore, the free body diagram of the piston with the negative force is drawn. A torque M of magnitude 1,500 Newton by meter is applied to the crankshaft of the engine for the position shown. Determine the force P required to hold the engine system in balance. B. The average normal stress is connecting rod BC, which has an uniform cross section of 415 millimeters squared. C. The shear stress in the input pin at the top of piston C if its diameter is 22 millimeters.
Good afternoon. This work is presented by Carlos Andrés Blanco, Nicolás Fernando, Johan Andrés Peña, Néstor Camilo Porras, Rubén Sánchez. We are studying at the leader of the University Foundation, and it will be the SMART project of the Professor Héctor Duzán. Summary. In the following exercises, a program related to the motor is based on the time ice that denominated different magnitudes that keep the system in equilibrium. It begins by calculating the force of need to balance the engine system. After this, the average and normal stringent stroke by analysis. As is considered the cross selections. Lastly, the straight stretch on the input pin and take up piston. C is evaluating taking its diameter into account throughout this exercise, skill in calculation forces and strength and complex mechanical systems are developed, providing a better understanding of engineering operation and design.